So imagine trying to force an entire fire hose's worth of water through a tiny coffee stirrer.
Right. It's not going to work.
Exactly. And that is essentially what happens when you try to push a modern 8K display signal through a standard copper cable. Welcome to this deep dive into an elite piece of AV hardware. We're looking at the DVIGear DVI-2820-AOC DisplayPort 1.4 cable, and, well, our mission today is to decode why a 20-meter cable costs $395.
Yeah, and I mean, that price tag really starts to make sense when you look at the sheer volume of data this thing is moving.
It's a massive pipeline,
Right, absolutely. It handles an aggregate bandwidth of 32.4 gigabits per second. To put that into perspective for you, that lets you run 4K resolution at a blisteringly fast 120 hertz refresh rate, or, even 8K at 30 hertz.
And it does all of this over 20 meters, too. I mean, it's about 65 feet.
Right, which is where things get really tricky for normal cables.
Because if you try to run standard copper wire that far, you hit what engineers call the distance dilemma. Standard copper relies on electrical pulses, and, well, those lose energy as heat the further they travel.
Yeah, the physics just work against you.
Exactly. So by the time a massive 8K signal reaches the end of a 65-foot copper wire, the data is just severely degraded.
Which is exactly why this is an active optical cable, or AOC for short. It actually converts that heavy data into light.
So it's sending it down glass fibers then?
Yeah, precisely. It bypasses that electrical resistance entirely, which allows for massive data loads without a single drop in signal quality. Plus, it maintains bidirectional communications for things like HDCP 2.2.
Ah, right, the copyright protection handshake that ensures your movies or protected content actually play.
You got it. Without that, you're just staring at a blank screen.
Well, I'm stuck on one detail here, though. Usually, if a cable is actively converting electrical signals into lasers, it needs, like, a bulky wall adapter to boost the signal.
Right, to power the optics.
Yeah. But looking at the specs for this DVIGear cable, there's no power brick at all. So, where is it getting the juice to push 32 gigabits?
That is the really clever part. The internal optical modules are just incredibly efficient. They draw a microscopic amount of power directly from the source device, less than 0.43 watts, actually.
Wait, really? Less than half a watt?
Yep. It completely eliminates the need for an external wall plug while still actively driving that pristine signal.
Wow. I mean, that lack of a power brick really highlights the hybrid construction inside the wire itself, I think, because it uses 4 discrete glass optical fibers, but it combines those with 6 copper members.
Right, which makes it incredibly versatile.
It's essentially a modern hybrid car. You've got the glass fibers acting as the high-speed engine for the heavy data lifting over long distances, and then the copper wires act like the electric battery, handling those low-bandwidth handshakes and sipping that tiny bit of power.
That is a great analogy, and that hybrid design gives it a huge advantage in professional installations, too. Because the glass fibers don't emit or pick up electromagnetic interference, the cable has an incredibly low RFI and EMI profile.
So it won't scramble the signals of other sensitive electronics nearby.
Exactly. It's totally interference-free.
And because it doesn't cause that electrical interference, this is exactly the kind of wire you'd permanently seal behind drywall, say in a high-end home theater or a professional broadcast studio.
Oh, for sure. It actually has the UL CMPOF Plenum rating.
Which means it carries the strict fire safety certification required to be safely installed inside walls and ceilings.
Yes, exactly. And running it through those walls is surprisingly forgiving. It has a highly flexible 35-millimeter bend radius. Plus, the connectors themselves are ultra-slim mini DisplayPort.
Oh, and it comes with detachable full-size locking docks, too.
Right, so you can snake the tiny, bare connector through a tight conduit in your wall and then just snap on the full-size adapter once you reach the monitor on the other side.
That is incredibly practical for installations.
It really is. So, whether you are future-proofing a professional workstation or setting up a high-end home theater or just running permanent infrastructure through your walls, you really have to realize that standard copper hardware just isn't going to cut it anymore.
Yeah, understanding the limits of standard copper helps you realize when fiber optic technology is the only reliable choice. Because as standard consumer displays rapidly march toward 8K resolutions and beyond, our data demands are only going to explode.
They really are. It's inevitable.
So it leaves you with this provocative thought. Are we approaching the day when traditional all-copper cables become entirely obsolete? Like, will these hybrid glass fiber cables become the mandatory standard for literally every single screen in your home? It's definitely something for you to ponder the next time you look at that standard cable on your desk.